why you actually need to turn on airplane mode. Picture this. You're sitting on a plane, 35,000 feet in the air, somewhere over the Atlantic. The person next to you is fast asleep, the cabin lights are dimmed, and somewhere in row 14, somebody's phone is quietly, invisibly, going absolutely haywire. Not because they're texting, not because they're watching a video, simply because they forgot to turn on airplane mode. Most people hear that and think, so what? It's one phone. What's the worst that could happen? Well, that's exactly what we're going to find out today. Because the real answer is not what the flight attendant tells you. It's not about your phone crashing the cockpit. It's actually about something way more interesting and, honestly, a little more unsettling, all while you're watching a movie and eating pretzels. Let's break it all down. First, you need to understand one thing. Your phone never really shuts up. Even when the screen is off and it's sitting in your pocket, it's constantly broadcasting. It's checking in with nearby cell towers, updating your location, looking for Wi-Fi networks, syncing notifications. This happens dozens of times per minute, completely automatically, without you doing anything. All of this communication happens through electromagnetic waves, specifically radio waves. Radio waves are essentially light that our eyes can't see. They travel through the air at the speed of light and carry information encoded in their frequency and amplitude. Your phone sends them out, a cell tower picks them up, and that's how you get your Instagram feed at 200 miles per hour above the clouds. Now here's where it gets interesting. Radio waves don't come in one single flavor. There's an enormous spectrum of them, ranging from extremely long, low-frequency waves, the kind used by submarines, all the way up to shorter high-frequency waves used by things like radar and satellite links. The frequencies used by your phone sit somewhere in the middle, in the range of roughly 700 M8s to 5 JATs, depending on which network generation you're on. And just like roads have lanes, the radio spectrum has channels. Every phone call, every Wi-Fi connection, every GPS ping gets assigned its own little slice of that spectrum so they don't all collide into noise. Cell towers act like traffic controllers, handing out these frequency assignments to every device in their range. When it works well, it's an invisible, elegant system. When it gets overwhelmed or interfered with, the whole thing starts to fall apart. So, what actually happens when you're flying at cruising altitude without airplane mode on? Here's the thing most people don't realize. Your phone wasn't built to be used in the sky. It was built for the ground. It was designed assuming that the nearest cell tower is, at most, a few kilometers away. When you're at 35,000 feet, that assumption completely breaks down. Up there, your phone can't find its usual tower, so it starts searching. And when a phone searches hard for a signal, it doesn't search politely. It cranks up its transmit power to the maximum, hoping something hears it back. That alone is already a problem. But it gets worse. Because at cruising altitude, your phone isn't just near one cell tower. It's potentially in line of sight of dozens of them simultaneously, spread across a huge swath of ground below you. Normally, towers are designed to only talk to phones that are nearby. When a signal suddenly comes blasting in from the sky at full power, it hits multiple towers at once, from angles they weren't designed to handle. The engineers have a word for this: tower overshooting. Your one phone, one single device, can land on multiple towers at the same time, none of which know what to do with it. This forces them to drop connections, reassign frequencies, and work overtime just to deal with the interference. And if there are 200 people on that plane, all with phones that didn't get switched off, multiply that by 200. This is why aviation authorities and telecom regulators have pushed for airplane mode not primarily to protect the aircraft itself, but to protect the cell network infrastructure on the ground. The cockpit electronics concern, which is what you usually hear about, is actually a much smaller part of the story, and one that modern aircraft are specifically shielded against. The dirtier truth is that your phone in the sky is a menace to the people below. Now, before we go further, if you're finding this interesting, do me a quick favor and hit that like button. It genuinely helps this channel reach more people, and if you want more videos that go deeper on the science behind everyday things, subscribe and hit the bell. I put a lot of work into these, and it means a lot. Alright, back to the skies. Let's zoom out for a second, because this is actually part of a much bigger problem. Radio spectrum is a finite resource. There's only so much of it, and every device that wants to communicate wirelessly needs a piece of it. Phones, Wi-Fi routers, GPS systems, emergency services, weather satellites, radio telescopes, baby monitors, they all share this invisible highway. And over the last 2 decades, the demand for bandwidth has exploded. When there's too much interference in the spectrum, the whole system degrades. Calls get choppy, data slows down. Devices start retrying their connections more often, which generates even more interference, which makes things worse. It's a feedback loop. And the more interference there is, the more pressure there is on network providers to claim more bandwidth, build more towers, and eventually launch more satellites into low Earth orbit to compensate. Those satellites are useful, but they come with their own cost. They add yet more radio noise to an already crowded spectrum. And once you start filling the sky with signal broadcasting hardware, you create a blanket of electromagnetic noise that covers the entire planet. Which brings us to the part of this story that I think is genuinely underappreciated. Radio telescopes. These are some of the most sensitive scientific instruments ever built by humans. They don't collect visible light like the telescope you might have had as a kid. They listen for radio waves coming from deep space, from pulsars, black holes, distant galaxies, and the faint cosmic microwave background radiation left over from the Big Bang itself. The signals they pick up are extraordinarily faint. We're talking about energy levels so tiny they make a snowflake landing on your hand feel like a sledgehammer. To work, radio telescopes need quiet. Real quiet. Radio quiet. Some of the most famous observatories in the world are built in remote deserts or mountain ranges specifically to get away from human-made radio interference. The Very Large Array in New Mexico, the Atacama Large Millimeter Array in Chile, the Parkes Observatory in Australia, they were all placed far from cities for exactly this reason. And yet, today, even these remote locations are no longer truly radio quiet. Satellites passing overhead constantly spill radio signals across the sky, and a phone operating on a 5G network can emit signals in the same frequency range that observatories need to observe phenomena within our own solar system. To put it concretely, the Very Large Array can observe signals across a range of roughly 1 to 50 gates. But below 5 gates, interference from modern mobile networks is becoming so severe that certain observations are increasingly compromised. Now, you might be sitting there thinking, okay, but I'm just one person. My one phone isn't going to blind a radio telescope or crash a cell network. And that's true. Individually, no single phone matters that much, but that's exactly how collective problems work. Nobody who leaves their phone on during a flight thinks they're the one causing the damage. But when millions of flights happen every day, and even a fraction of passengers skip airplane mode, the aggregate effect is real and measurable. This is one of those situations where the rules exist not because any single person's behavior is catastrophic, but because the behavior of everyone together adds up to something that genuinely matters. So let's come back to the original question. Does airplane mode actually protect the plane? Mostly, no, not in the dramatic way people imagine. Modern commercial aircraft are built with extensive electromagnetic shielding. The avionics and navigation systems are hardened specifically because the aviation industry has always known that electromagnetic interference is a real-world concern. The idea that a phone could send a plane off course or disable its instruments is, for modern aircraft, essentially a myth. It was a more legitimate concern in the 1990s and early 2000s, which is probably when this idea got baked into public consciousness. But aviation technology has moved on considerably since then. What airplane mode does protect is the world below you. It stops your phone from becoming an unintentional jammer. It prevents your device from hammering cell towers from impossible angles at maximum power. It reduces the aggregate load on a spectrum that's already stretched to its limits, and in a small but real way, it helps preserve a little bit of radio silence for the telescopes that are trying to read the cosmos. When a flight attendant asks you to switch to airplane mode, they're probably not thinking about any of this. They're following a procedure. But behind that procedure is a genuinely fascinating web of physics, engineering, and infrastructure that connects your phone, 35,000 feet in the air, to a radio telescope in the Atacama Desert trying to catch the echo of the Big Bang. Next time you tap that little airplane icon, you'll know exactly what you're actually doing. If you enjoyed this video, hit like and leave a comment. I'm curious. Did you always use airplane mode, or are you one of the secretly guilty ones? No judgment. Subscribe if you want more of this, and I'll see you in the next one.